Infinite and no solutions. So, up until this point, we've always had solutions that had one answer. So, we were able to solve for x and get x by itself on one side. That's still our sort of goal, but something funny happens. And so, in our first one example, let's think about what could happen if we substitute a number in. So, if we substitute, say, x equals 1 in for this equation? Well, if x is 1, that would be 1 equals 1 plus 1, which is 2. Wait, that doesn't work. So 1 doesn't work. What if I substituted 2 in? If I substituted 2 in instead of 1, I'm going to have to get 2 equals 3. Well, what if I substituted 9 in? Made x 9. So that would be 9 on this side, and 9 plus 1 is 10 on this side. So that means, wait a minute, that means like any number I put in, the right-hand side will all be one more, always one more on this right-hand side. So no number that I will substitute in will work. So how does it show up and that's our solution actually. That is it's no solution is our answer. But what does it look like if I solve it like our equation? So again, this is our answer that we're going to get. We're not going to get an x equals answer. But let's see what happens when we solve our equations. So our solving equations, we want to get x's by itself on one side. So I see I have an x over here with the 1, so I want to move that over to the right-hand side. So I'm going to subtract x to zero that out, and if I do it to one side, I have to do it to the other. Wait a minute. X minus x is 0. It kind of does the same thing over that happened over here on the right-hand side. So I could cancel that out like this, but I want to make sure there's nothing, well, there's nothing else over here. I want to make sure that I write down my 0. Normally on the right-hand side, we kind of think, oh, it zeroes out plus 1 is just 1. So we bring down that solution. But this actually is 0. I don't show it on the right-hand side because I'm taking 0 plus 1. So I just put the 1 down because it's anything plus 0 is that self. And over here on the left, though, I need to put that number down there. So I look at this equation and go, wait a minute, 0 does not equal 1. So what we do mathematically is put a little slash to the equal sign, and that just means 0 does not equal 1, which is true. Now we have a sort of a false statement right here. This is false. But we don't circle this. Normally we'd circle x equals 1 right here, but we don't circle that in infinite and no solutions. These are special cases. So I'm going to write that over here, special cases. And this is what happens when we get into the algebra part of our solving equations. When we start solving equations, more complex problems, what happens is that we get these situations where there are no solutions that work. So we have, notice I circled no solutions as my answer, not the 0 doesn't equal 1. I circled the no solution. So this tells me it's false, and there's my answer. So let's take a look at another example that would be infinite solutions. So let's take a nice, easy problem. 2x equals 2x. So if I think about a number I can put in for x, like 1, 1 times 2 is 2, and 1 times 2 is 2. If I try 2 in for x, that would be 4 equals 4. If I try 9, that would be 18 equals 18. So no matter what number I substitute in, it will always be true. So what we call that is an infinite solutions. Now, infinite meaning all solutions, and that's what our answer is. Now, some textbooks like all real numbers, That would be another way to write infinite solutions. Or they use another property. It's called the identity property. Identity property. And what property? And what that means is that identity property means that A equals A. And it just means that one side equals itself. It's always going to equal itself. So some textbooks like that way to write it. I prefer myself. I prefer this infinite solutions because it kind of thinks about that. There's an infinite number of answers that would work in this equation. Now, what we're going to do is like up here at the first one, we're going to solve it. So right now, it sort of looks like I can't do anything, but what we can do is get the x's together. Right now, they're on both sides of the equation. So like up here, my x was on both sides, so I subtracted x from both sides. So I'm going to do that here, except I'm going to subtract 2x because I want to zero this one out on the right-hand side, and I want to, I have to subtract 2x from both sides, and I see this is that why it's special cases. It feels kind of weird because what happens over here? These also zero out, so we get 0 equals 0. And wait, 0 does equal 0, so that is a true statement and different than the false one up here. So the true statement means that it's an infinite solution. So we might get other problems that might say 7 equals 7, and that would be an infinite solution. Or it might say 2 equals 2. Notice it's different, not 2x equals 2x, but 2 equals 2. The number equals itself. That's a true statement. So that would be then our infinite solutions. So now what happens is those were kind of easier problems, and we get into equations that are a little bit more complicated, and we don't see that it's an infinite or no solution. So we've got 3 minus 4x equals 7 minus 4x. So this one, our goal is to get x by itself. Now, what happens a lot of times is students like to, or some people, they stay as far away from the variables as possible. So they cancel out that 3 first, which you can. I find more helpful to get the x's by themselves first. Get the x's by themselves first, and then you actually save yourself a little bit of work. You don't have to do as much work. So I want to move this negative 4x over to the other side with the other x. So I'll just add 4x to both sides to zero that left-hand side. So add 4x to this side, and that one also zeroes out. So that's 3 plus 0 is 3. Bring down my equals right in the middle. And 7 plus 0 is 7. And does 7 equal 3? And it doesn't. 3 does not equal 7. So I'll put a little slash there. Now remember, that's not I don't circle that. I circle no solution because no solution will work in this original equation. So no x, any number for x, will never be equal here. So our fourth example is a much more complicated one. And I almost saw that there was something funny here. So don't freeze, just do what you normally do in solving equations, getting x on one side by itself. Now, this next example, it's a little harder to see. So 6x plus 4 equals 4 times 3 halves x minus 1. So, I don't see anything. I see that I have a distributive property here, so I can take 4 and multiply it by each of those. So I'll bring down my 6x, bring down my plus 4, bring down my equals right below it, and then 4 times 3 halves. So I'll do a little sideline math. 4 times 3 halves. Ooh, don't forget the x. But I'm going to do my calculation over here without the x. So 2 goes into 2 once, 2 goes into 4 twice. So I see that there was 2, cancels out. Oh, so 1 in the denominator, and 2 times 3 is 6. So that would be a 6x. And then minus, because 4 times a negative 1 is a negative 4. So, and I kind of now see that there's something funny going on. It's either a no solutions or infinite solutions, but I'm going to keep on solving, keep on solving, keep on solving, and subtract 6x from both sides. That zeroes out and that zeroes out. So 0 plus 4 is 4. Bring down my equals right in the middle, and 0 plus a negative 4 is a negative 4. And I ask myself, does 4 equal negative 4? And it does not. So this one would be a no solution. Now it almost looked like it was an infinite solution. That would have been a 4 equals 4. They had the same digits, but one's positive and one's negative, so that makes it a no solutions. And that is how you solve infinite and no solutions, those special cases, is getting your x by itself first. It just kind of helps because then you don't have to move the 4s over to the other side or the 7 to the or the 3 to the other side. You save yourself maybe 1 or 2 steps of solving.